All right, welcome to topic number 19, polynomial inequalities. So in topic 18, I show you how to graph those polynomial functions. So now we're actually gonna, instead of using equal sign, we're gonna use inequality signs. Okay, so this concept right here is about the graphing part. Okay, so where are the function equal to zero at, or where are y equal to zero? That question I asked before is really about here. You know, when y is zero, okay, when y is zero, or where the function is equal to zero at, is referring to what's on the x-axis. So what's on the x-axis when y is zero, that's referring to the zero of the function. That's also referring to, the x-intercept. Okay, but here it also means what's on the x-axis, right? So when I'm changing equal sign to inequality, if I say the function is greater than zero or y is greater than zero, that means we will need to look at the graph, the part of the graph that's above the x-axis. If there's an equal to, that means we're gonna look what's on the x-axis and the graph and the other part that's above the x-axis. Okay. Less than zero means we will look at the graph that's below the x-axis. With the equal to, we're gonna look what's on the x-axis and below the x-axis. Okay, so this inequality later on will tell me where I need to look at my function once I graphed it. All right, so how do we find the polynomial inequalities? Well, number one, we're actually gonna find the x-intercepts. Okay, these are also called the real zeros or critical points of the polynomial function. And then we're gonna graph it. We're actually gonna graph it in the graphing calculator, okay? And then once we graphed it, and also found the x-intercept, okay? Those x-intercept are your critical points. So if you know what they are, then you can easily state the solution using the interval notation. So real easy, show you what to do here. This is already factored in, okay? So this example, all I have to do is set each factor equal to zero. I know there's a -1 in the front, but this -1 does not contain, oops, let me see what happened there. This -1 does not contain any variables, so I don't have to set that equal to zero. So I set x plus 3 equal to zero, and I set x minus 3 equal to zero. And you can see the multiplicity, right? Multiplicity here is even, that's odd. So this is actually x to the third power. This function is actually going to say x to the third power. All right, find the x-intercepts by solving for x. So move the positive 3 over. So that'll be x equal to -3. So my one x-intercept is at -3 comma 0. Move the positive 3 over, x is equal to 3. The other x-intercept is at 3, 0. All right, find the y-intercept. All right, find y-intercept means find y when x are zeros. So I'm going to substitute 0 into my polynomial equation or functions. So that'll be negative parentheses 0 plus 3 times 0 minus 3 whole thing squared. So negative sign, right? 1 times 0 plus 3 is 3 times 0 minus 3 is -3. -3 whole thing squared. -3 whole thing squared is positive 9. So -1 times 3 times 9 is -27. So I have a y-intercept at 0 comma -27. All right, graph the polynomial function. So same thing as earlier. All right, I'm gonna do my x-intercept, my y-intercept is way down there, okay? So think about this. X times x squared, right, is x to the third power. This -1 in the front multiplied by my entire function, that will tell me my leading term should be negative x to the third power. So by the leading term test, I know I know my graph should look like scribble, scribble, scribble. Okay. Left side goes up, right side goes down. All right. So let's do some uh intercepts. Negative 3, 0 and 3, 0. Okay. Y-intercept way down here, 0 comma negative 27, way down there. All right, so you know from left to the right, this left side is going upward. So my multiplicity, oh, gotta think about my multiplicity real quick. At 3, 0, okay, this 3, 0 come from x equal to 3, which come from x minus 3, which come from right here. The multiplicity on the x minus 3 is even, so it will turn at 3, 0, it cross at negative 3, 0. All right, so before I even graph it, I need to think, okay, at negative 3, 0, it will cross. So it will look something like this. All right, coming down from negative infinity, right, coming from very left, cross over the x-axis. Oops, not very pretty. Cross over negative 3, 0, come all the way down here. All right, to the y-intercept, and then come back up, right? Approaching 3, 0, but once I reach 3, 0, I have to turn down again. So it looks something like that. All right, if you don't believe me, we can graph it. So a little bit tricky to graph. All right, negative parenthesis x plus 3, close parenthesis, open parenthesis, x minus 3, close parenthesis, whole thing squared. Okay. Coming down, y-intercept is way down there, come up and go down again. So by knowing how to grab by hand, it tells me, it tells me what I'm looking at makes sense. Coming down to y-intercept, go back up, and then once we reach 3, 0, it curve back down again. All right. Now, number 5, highlight the part of the graph according to the inequality. My inequality, if you read from the variable, this is actually saying less than or equal to. All right, reading from the variable, if it says less than or equal to 0, that means we will look below the x-axis. Okay, there's an equal to, right? Less than or equal to. Below the x-axis. All this are below the x-axis. So when I write my solution using interval notation, then the part that's below the x-axis from left to right must be from negative 3, right? Using a brackets because I'm actually look what's on the x-axis and below. With the equal to here, I have used brackets. All right, my below the x-axis is from negative 3, right? All the way to 3, but also gotta keep on going to the right. So you don't say from negative 3 to 3, and then from 3 to infinity, because you're including 3 twice. So you don't have to do that. You can just say from negative 3 all the way to infinity. That part of the function is actually below the x-axis. Okay, you can do it like that. You did not really have to do it like negative 3 to 3, right? That part is below. And then union from 3 to infinity, which is that part. That's kind of redundant a little bit. All right, so that's all you do with the polynomial inequalities. You find the x-intercept or the critical points, you graph it, then you look at, based on what the inequality says, then that tell you where you need to look on your function. Okay, and that's how we state the solution. Let's try another one. All right, consider the following polynomial functions. Okay, so if you read from the variables, right now, this is actually saying greater than equal to 0. So in a minute, when I am, when I need to write my solutions, okay, I need to highlight, I need to look above the x-axis. All right, find out the greatest common factor between the first two and the last two terms. So factoring by grouping again. Between the first two terms, I can factor out x squared, so that leaves me with x minus 5. Between the last two terms, I can factor out -1, so that will give me x minus 5. Why? Because I want the parenthesis match. So between the last two terms, factor out -1. All right, so now there should be two terms left. Sorry, two terms left. All right, factor out the greatest common factor again. So that will be x minus 5. If I factor out the greatest common factor, x minus 5, what should be left for the two terms are x squared and -1 greater than 0. All right, factor the difference of squared, which is right here. So there will be x minus 5 times x plus 1 times x plus 1. -1 and +1. So if you look, this is the factor, right? The multiplicity up here are 1. They're all going to be odd. So when I graph it, I know my graph will cross at these three x-intercepts, or these three zeros. Set each factor contains a variable equal to 0. All right, find the x-intercept by solving for x. Move the -5 over. X is equal to 5. So 5, 0 is 1 x-intercept. Move the -1 over. X equal to 1. 1, 0 is another x-intercept. Move the +1 over. X equal to -1. -1, 0 is the other x-intercept. All right, find the y-intercept. So I gotta go back up. Look at my function again. All right, x to the third. Y-intercept. Find y. Oops. Find y when x equal to 0. So if I substitute 0 for all the x, all right, so once all these are zeros, so that should be just 5, right? Y-intercept 0, 5. Okay, so let's graph them. Plot the x-intercept. 5, 0. We make this a little bit larger. 5, 0, 1, 0, -1, 0. 5, 0, 1, 0, -1, 0. Y-intercept 0, +5. That'll be up here. All right. So if I look at my function, x to the third power, okay, Degree is odd. Leading coefficient is positive. Scribble, scribble, scribble. Right side goes up. Left side goes down. All right, so I know I will cross it, right? So from left to the right, I must come in from down here, right? Cross over this x-intercept, go to the y-intercept, come back towards the other x-intercept, cross it, and cross it. There you go. Look, something like that. Something like that. Good enough sketch. X to the third minus 5x squared minus x plus 5. Coming up, go down. Yeah, it's close enough. This is a little bit more down. All right. So now remember the inequality. Greater than zero, read from the variable. Greater than zero means I need to look above the x-axis. Okay. The part of the solution is going to be above the x-axis because only the coordinates, okay, of the function of this function above the x-axis will actually satisfy the inequality. So that will be right here. It's above the x-axis and right here. So I got two places. It's above the x-axis. So number 8 tell me to highlight. Number 9 tell me to state the solution. So remember this x-intercept is -1. So from -1 to 1 is above the x-axis. All right. Since because there's no equal to, because this is only greater than 0, so that means I'm only looking at what's above it. So I'm not including the -1 and 1. Okay, they are my critical points. I need to use them for reference, but since there's no equal to, I do not include them as part of my answer. So the part of the function that's above the x-axis from -1 to 1, okay, union. The other part got to be from 5. Keep on going to the right. Those parts. So basically what it's asking is this solution, what the solution is saying is from where to where on the x-axis the function is above the x-axis. Okay, -1 to 1, 5 to 0, to infinity. Okay, from where to where, okay, from where to where on the graph the function is, excuse me, from where to where on the x-axis the graph is above it, above the x-axis. Okay, that's the way what this question is asking. Now, if you've seen something similar to this before, there's another way to actually describe this. Sometimes the teacher might show you like a number line, and they're gonna have -1, +1, and a 5 right here, and they're gonna tell you to enter x value here to the left side of -1 and plug it in and see what the y value is. Okay. So what this number line, if you ever seen this before, what this number line is literally telling you is what we actually just graphed it. Because the part that will actually give you positive y value is the part that's above the x-axis. To the right of 5 and between -1 to 1, the y value will be greater than 0, which is above the x-axis. Therefore, the y values are positive. Everywhere else is negative. So this way teaching it is basically doing it by the graph. By the graph, it is easier because you can see the part that's above the x-axis, so you don't have to substitute numbers, back into the function, do more work. This is a little bit easier just by looking at the graph and say, just by looking at it to know where it's above the x-axis. Okay. All right, let's go over the homework real quick. I want to bring the homework over. I think. All right, question 1 is on the handwritten portion. So what I want you to do first, okay, is factor out the greatest common factor between the first two and the last two terms. Number 2, there should be 2 terms left. We'll change that to left. All right, so once you factor the greatest common factor between the first and last two terms, there should be two terms left. Factor the greatest common factor again, and then factor the difference to square, just like I showed you earlier. And then set each factor equal to 0. Number 5, find the x-intercept. Make sure you write them as ordered pairs. Find the y-intercept for me for number 6 and number 7. Plot the x-intercept, y-intercept, and use the leading term test and multiplicity to actually draw your graph. Okay. Highlight the part according to the inequality. So if I scroll back up, this problem, according to the inequality, reading from the variable is greater than or equal to 0. So I need you to highlight the part that's above the x-axis. Greater than or equal to 0 means look what's on the x-axis and above. And number 9, tell me what the solution is using the interval notation. Okay, so stating the solution means stating the solution that the part that is above the x-axis. All right, so that will conclude this quick video on the polynomial inequality.